Okay, so we're going to be looking at what are the six trig ratios that we're going to be working with through the term. Okay, there's six different ones. Okay, we're going to review what the quadrant system looks like in our unit circle. And then we're going to do some examples with exact values today. And tomorrow we're going to do examples with approximate values. Okay, so we'll start with looking at what the six trig ratios are. We've got sine, cosine, and tangent, which are called the primary ratios. And then we've got the reciprocal ratios, which are secant, cosecant, and cotangent. So we're going to look at those six, what they are, what the formulas are. Again, when we do a hand-in and when we do a quiz and stuff, there will be a formula sheet, of course. So if you're looking at the basics of the unit circle, let's just draw it or a circle here. Real quick, we'll put a little circle right here. Make a center. Throw that down there. Okay, and if we're just kind of doing a sine, cosine, and tangent, we put a radius up. And then we put the x component and the y component of our triangle. So here's our angle. Oops, that's a bit fat. Squeak. Put that skinnier there. This is radius. This is x. And this is y. So if you went on this point here, that would be xy. Okay. Now in the unit circle, r is 1, right? But in it, this applies to all circles and all triangles and all ratios. So r doesn't always have to be 1. It could be some other number, which it can be, depending on how big your circle is. Okay, so the trigonometric ratios, as you rotate around this circle, you have sine, which is y over r. Okay, if it's a unit circle, it's just y. But if it's a regular circle, it's y over r, depending on what size r is. You have cosine, which is x over r. Okay, and if r is a unit circle, then it's just x. You have tangent. And tangent is opposite over adjacent, or y over x. Okay, so there's your primary ratios. These are, we call these ones primary. Okay, and we use those a lot. Okay. Okay, we can use them with approximate values with a calculator, decimal values, and we can get exact values for special triangles. Okay, and then the reciprocal ratios. Okay, so reciprocal ratios. So with sine, we have cosecant. That's cosecant. And it's basically the reciprocal of sine. It's r over y. Okay, and with cosine, you get secant. And it's basically r over x. And with tangent, you get cotan, which is flipping over tangent. Cotan is like this. and that's x over y. Okay, so there's our 6 trig ratios that we use. Now these here over here, you'll notice that there's like one that doesn't have a co in it and the other one has co, the reciprocal has co. So sine and cosecant, cosine and secant, tangent and cotangent. That's kind of how they're paired up. Now you don't have to memorize those. Those will be some result that you can look up on a formula sheet for exams or hand-ins or anything like that. Okay, and those are our basic ratios. Now if we look and we take this circle here, doesn't necessarily have to be unit circle, but and we break it into the 4 quadrants as the unit circle is, you can have values that become negative and positive values based on what the value of x is, what the value of y is. Now r is always considered to be a positive value because it's the radius and it's considered to be the hypotenuse, and we square it and it always comes out positive. Okay, so r is always considered a positive value. So this leads us into reviewing what happens in the quadrants of the ratios of these 6 trig ratios. Okay, so if we go down, we'll slide down a little bit. And if we were to draw a quadrant, okay, now we're not going to bother putting in the circle. We'll just have the quadrant. So to remind ourselves, the math labeling, we always consider the top one here in the top right to be the first quadrant, which we label with a Roman numeral traditionally. This one's 2, this one's 3, and then we have 4 over here. So in quadrant 1, x is positive, y is positive. So everything is positive in quadrant 1. Sine, cosine, and tangent are all positive. So sine is positive. Cosine is positive. And as well, tangent is positive. They are all positive values. Okay, that means that the reciprocal identities are positive as well. Okay, so cosecant, secant, and cotan are all positive. So everything in here is positive. All are positive. So we use the letter A to represent that. So we say everything, all is positive. Now when we move into the second quadrant, x and y is still positive because it's going up, but x is now negative. So now when we look at our formulas, if I just slide back up to the top here, anything that has an x in it will become negative. Positive y over positive r, that sign is positive. Negative x over positive r, negative positive y over negative x. So the cosine and tangent are negative. As a result, cotan and secant are negative. So that means sine is positive. The only thing that's positive is sine and cosecant. So we know that sine is positive here. Okay? And by relationship, that means cosecant is positive. So that means the rest is negative. Cosine and secant are negative, and tangent and cotangent are negative. Okay, so we just go, if we're just looking at the primary ratios, we say sine is positive. Okay, and the reason I'm doing that sign there first is because it's going to spell a nice word around here that will help you memorize this stuff. Okay, number 3, we have both negatives. Negative x and negative y. So that means everything with a y and an x and an r in it is negative. And the only thing that's positive is the x over y. So this is negative, negative y over positive r, negative x over positive r, negative y over negative x. Negative over negative is positive. So tangent is the only positive one, along with cotan if you look at the reciprocal identities. So in this case, we have tangent is positive, and sine and cosine are negative. And if we look into the reciprocal identities, that means cotan. And with sine, we have cosecant. And of course, we have secant. Okay, and the last one, we've got a positive here and a negative y. So thinking about that, anything with a y in it and an r in it is negative. Anything with an x in it and an r in it is positive. So the only thing that has a y in it with the r, okay, that's negative. X and r, that's positive. A y is negative. The x is positive. That's positive. So this time cosine is positive for the ratio. Cosine, sine is negative, and tan is negative. Okay, and you can also do that with the reciprocal identities. So if we're looking at cosine there, that goes with secant, and then sine goes with cosecant and cotan. Okay, so there's a rule that we usually use here. If we just look at the first letter of the primary if we just look at the primary ones, all are positive here, so we could spell the word cast as we go around. So in math, we call this the cast rule. So cosine is positive and its reciprocal identity. All are positive. Sine is positive. Tangent is positive. Everything else is negative. Okay? And of course, you always have to include the reciprocal identity that goes with it. But if you're just looking at the primary ones, you can look at the cast rule. And that's important when we're using the unit circle. Later on when we're doing reference angles, doesn't really matter too much with the unit circle because we have the signs on them already, right? Because they're already on here. But when we get into doing the reference angles with decimals, probably tomorrow, then we have to decide whether it's going to be a positive or a negative value. Your calculator always gives, will give positive and negative values, but it's not always right because of it works with reference angles. And I'll explain that probably tomorrow. So there's the first two goals for today. Here's the 6 trigonometric ratios. Not needed to memorize that, but it doesn't hurt if you can. But it'll be on a formula sheet. And here is the cast rule. When is sine, cosine, and tangent positive? And by relationship, that also goes towards secant, cosecant, and cotangent. So those are the first two things we wanted to look at today. So the last thing we're going to do today is we're going to look at using the unit circle and do some examples of how we calculate values of sine, values of cosine, values of tangent, or things like that. Okay? And we're not necessarily going to just use the unit circle. all the time. Okay, so we're going to do a couple examples. And then tomorrow, we'll get into using, because we probably won't have enough time today. Today will probably be like a 35-minute class, so we won't be able to get it. And then we'll get into our calculator. Okay? And then your calculator, you have to know how to switch between radians and degrees on your calculator, because you'll use both in this unit. You'll use both degrees and radians. So remember, most calculators have like a DRG button, and remember DEG means degrees, or D means degrees, and R means radians. And there's also another one on some calculators called gradians. We don't use that at all. That's for like later on, way later on. Okay, so we're just using radians and degrees. Okay, so let's do some examples here. Let me pop up my example sheet here that I've got some already made, I think. All right, so I'll flip the page here. And we're going to say, say that this point L, we'll call it point L, and let's say it's negative 1/3 over 2 root 2 over 3. Okay, this is on the unit circle. Okay, it's not one that's 30, 60, 90, or 45-degree special triangle. It's one in between. Not one on the unit circle. So that means that if we took this and squared it and that and squared it, we'd get 1 for the radius. So then we know that x is negative 1/3, y is 2 over root 2, or 2 root 2 over 3, or 2/3 root 2, and r equals 1. Okay, so find the trig ratios in exact form. Okay, later on, we'll probably have decimals in there, and we use our calculators and stuff. Okay, so we know that sine, if we look at our formula sheet there, it's y over r. Okay, so if I take y is this here number, 2 root 2 over 3 divided by 1, so that's the same thing. And you'll find that the sine value is always your y value on the unit circle, because r is 1, right? Okay? Cosine, same thing. It'll be this one here. Cosine is x over r. So that's just going to be negative 1/3 over 1, which equals negative 1/3. Pretty easy to do, right? Okay. Tangents. Okay, tangents a little different. We have to do a little bit of dividing. Tangent, when we look at the formula, it's y over r. Or sorry, y over x, pardon me. So the bottom number is not going to be a 1. So it's a little bit more complex. We have to take our y value. Okay, so our y value is 2 root 2 over 3. And we have to divide by negative 1/3. Okay, so we know how to divide fractions. We just take the reciprocal of the bottom and multiply. So this is the same thing as saying 2 root 2 over 3 times 3 over negative 1. These cancel out here, and we get 2 root 2 over negative 1, which is negative 2 root 2. So when we're doing the tangent one, that's where we have to do a little bit of math, a little bit of fraction math. Okay, also you could probably figure it out here just because they both have 3's, they would have canceled out and then gone to this step as well. Don't necessarily have to do that. Okay, so that leaves us with the second part, taking the reciprocal of these to get the ratios for the reciprocal trig ratios. Okay, so let's do that. All right. Let's slide down a little bit here. Okay, so sine is y over r, but if we take the reciprocal of sine, we get cosecant. Okay, cosecant, all right, that's going to be just flipping this over. It's going to be 1 over 2 root 2 over 3. So then it's going to be, if we write it out the long way, even though we don't have to, and then that's just going to be 3 over 2 root 2. Now we know from pre-calc 20 that we can't just leave a root 2 on the bottom. So we have to rationalize it. Okay, can't leave it like that. We have to rationalize it by multiplying by 1, which is 2 root 2 over root 2. Anything multiplied by 1 is itself. So this is going to become 3 root 2 over 2 times root 2 times root 2. Root 2 times root 2 is 2. So this is 2 times 2 on the bottom. So that becomes 3 root 2 over 4. When we do the rationalization of that particular one. Okay, so we have to do the same thing for cosine. Now cosine is much easier because there's no roots in it. Okay, it's just negative 1/3 over 1, so I'm going to flip that over, 1 over negative 1/3 for secant. Secant is the upside down, that's r over x. In our case, we're just going to take this, flip it over, 1 over negative 1/3. Okay, we know that that is negative 3. That one's a little bit easier to do. Okay, and the last one is to do cotan, which is going to be this thing flipped over here. Okay. Now, you notice that I'm doing it right from the formula for all of them, but if you've done the ratios, the primary ratios, you could just flip these over and get answers too. The only risk with that is if you made a mistake. Then you'd make 2 mistakes. Okay, so our last one is cotangent. So cotangent theta. So cotangent theta is x over y instead of y over x. We're looking up here. And it's these two flipped around. Or this one flipped over. Let's do it the long way, just in case, just to show that. So this would be negative 1/3 over 2 root 2 over 3. Okay, so again, we're going to flip this over and the 3's are going to end up canceling out. Okay, making sure I keep that negative in there. So I got an answer of 1 over 2 root 2. Okay, again, we're going to have to rationalize that as we learned way back in pre-calc 20, that we can't leave a root on the bottom of something. So we're just going to multiply by root 2 over root 2. So this becomes root 2 over, okay, this is the same multiplication as we did up here. It's 2 times root 2 is 2, and it's 2 times 2. 2 times 2 is 4. So here is our complete set of answers. Okay? And I should have a negative in there, shouldn't I? Right? That's a negative. Don't want to mess my negative up. Okay? So this one here, we've got this one. Let's do blue. This one here. Okay, and we got this one here. Okay. And then we have our tangent here. And we should have two positive and 4 negative based on how the quadrants work. Because this will be located in some quadrant. Now, do we know what the angle is? No. Because it's not a perfect, it's not a root 2 over root 2 or it's not on here. Okay, so if it's not on here, it's in between some of these angles. We can still find it by just using our calculator and breaking these down into like decimal numbers and getting an approximate value. But that's what we're going to kind of work on tomorrow, is using the calculator. Today we're looking just specifically at things that are on the unit circle, and then we're going to do one. We're going to do some that deal with this type of stuff here. So we'll do one more yet today. I'm not going to assign any practice today. I'm just going to do some examples today, because tomorrow is kind of when the practice happens. We got to, and it's a little bit too hard to squeeze both ideas into one period, because both ideas into one period causes confusion in my sometimes if you go too fast. So we're going to do one idea per period. Okay, so let's do some basic stuff using this unit circle. Okay, so I'll flip the page here. And these ones are a little bit simpler than that one. That one was a thing that was on the unit circle, but it was in between the given ones that we have on our drawn circle. So this one's just going to be determine the determine the exact value of each ratio. Okay, and we're going to use the unit circle. All right, so first one we're going to look at is, we'll do tan. Well, let me use my marker because I got to put pi in here because I'm going to do some radians and some degrees as well. Okay, so let's say our first one we're going to do a few of these. Let's do tan of pi over 2 radians. Okay. All right, so let's do that one. We'll call this one A. Okay, looking at pi over 2, we know that on the unit circle that the x value is 0, the y value is 1, and the r value is always 1. So we look at the tangent formula. So if you look back on the last page, tangent of that pi over 2 is just simply saying, I'll write the formula, y over x first. In our case, that's going to be 1 over 0. What do we call 1 over 0 in math? We call that, can't divide by 0, right? So we call that undefined. but we just look up the two x and y values. Okay, now you notice tan is not on here, so you have to use the formula to calculate it out. X and y are both on there, or if you look, it's cosine and sine are right on there. Okay, so that's fairly simple. Okay, and that was using radians. Let's do a negative value. Say I have sine of negative 300. Okay, and we're going to do degrees this time around. Okay, so the first thing you got to do is you got to figure out where negative 300 is on the unit circle to figure out where it is. So I'm going to convert it to a positive value. Okay, so if we're going down 300 degrees, we know the circle is 360, so it's going to be the same as saying positive 60, right? So we're going to say that this is equal to sine 360 minus 300. So sine 60 degrees is the same spot as sine negative 300 degrees. Okay, one you go up, the other one you go down and around, and you hit the same spot. So now if we look at this, we can just look up sine 60. Sine 60 is the second point on the unit circle, so it's root 3 over 2. Okay, pretty easy to look that one up. It's right on there. You see, it says cosine and sine, or x and y. They both mean the same thing because it's a unit circle. Okay, what if you get a reciprocal identity? Notice that reciprocal identities are not on here. Okay, you just use the formula. So let's say I had the cosecant. Let's try. Let's say cosecant of, let's go 7 pi over 6 radians. Okay, so, okay, in this case, we're going to be looking for the 7 pi over 6 spot. On our area. Okay, so that's in the third quadrant. Okay, so now we're going to just, okay, our x value there is negative root 3 over 2. And our y value there is negative 1/2. And that means our r value is still 1. Okay. So now we can go back and look up cosecant. Okay, so cosecant is related to sine, right, as a reciprocal identity, but if you're not sure, you look back and see what it is. So this would be the same thing as saying, well, that's r over y. So in my case, or in our case, pardon me, r is 1, and y is negative 1/2. Okay, so we just do the division there. We take the reciprocal and flip it over. So that's negative 2. So the cosecant of 7 pi over 6 is negative 2 on that. Okay. Questions? Pretty straightforward, right? Not too bad. Okay. That's the first section of instruction today. Actually, I'll give you a little bit to do. I'll give you one question to do for practice. Okay, so that takes us to about 36, 37 minutes. I don't want to go any farther. The next stuff that we're going to do is going to be using our calculator, and it's a little bit more difficult. This stuff is more looking up stuff and using the formulas. Okay, my recommendation is to take your unit circle here and on the back of it, write your sine, cosine formulas and all that formula stuff on the back so you can remember that. If you think you can remember it without that, don't bother. But it does help. If you're looking up stuff, you go, oh, what's tan? X over Y or Y over X. I can't remember. Oh, let me look it up. So go ahead and do that. And then for practice, just do on page 201, number 1 for today. And we'll save. And we will save the second part of the instruction doing calculator. This is 4.3 that we're doing for our next day. Okay. So before I stop the vid, any questions? All right, so that's our instruction part for today. Rest of it's just working. I'm going to stay online for a few minutes in case there's questions. And I'll stop the video here and save everything to the Google page.